Imagine building a user registration form for a production-grade web application, one that instantly guides your users, validates every keystroke, and delivers seamless, real-time feedback, all without bloating your project with heavy third-party libraries. Now picture achieving this level of dynamic interactivity and reliability with pure, modern JavaScript. No dependencies, no hidden complexity, and complete control in your hands. This is where the JavaScript proxy pattern changes the game. In this tutorial, you're about to unlock a powerful, underutilized native feature of JavaScript that lets you intercept and control every change to your form state, enabling you to craft dynamic validation and real-time feedback systems that rival the best library-driven solutions, while keeping your code base lightweight, secure, and fully maintainable. You'll discover how to intercept user input as it happens, enforce complex validation rules directly in your logic, and instantly update error messages and UI feedback, all in a way that's framework-agnostic, highly scalable, and ready for the demands of serious, production-ready front-end applications. If you're tired of wrestling with library-specific quirks, worried about performance or security, or just want to master a modern approach that gives you full ownership of your front-end logic, this lesson is for you. We'll break down the Proxy API, show you how to build your own validation engine, and walk through real-world patterns you can use in any project, from e-commerce checkouts to enterprise dashboards. By the end, you'll not only understand the proxy pattern inside and out, but you'll also have the skills to implement robust, dynamic, real-time validation and feedback systems in your own applications, with zero external dependencies. To keep leveling up your front-end skills and stay ahead with cutting-edge practical tutorials like this, make sure to subscribe and join our community of developers dedicated to building better, smarter web applications. Imagine a form as a living contract between the user and your application. Every field the user fills out is a promise, a username that must be unique, an email formatted correctly, a password strong enough to protect. Traditional validation is like a vigilant doorman who checks credentials only at the very end, sometimes letting errors slip by until it's too late. The JavaScript proxy pattern transforms this experience. Instead of waiting for the form to be submitted, the proxy acts as an ever-present, invisible guide, scrutinizing each input in real time as the user interacts with the form. It wraps the form's data object, intercepting every attempt to change a field. When a user types into the username field, the proxy catches the new value instantly, runs it through validation rules, and updates the error state if anything is amiss. The user gets immediate feedback, an error message appears, the input box turns red, and guidance is offered without delay. This dynamic, fine-grained control is achieved through the proxy's ability to intercept set operations, which means that every field update becomes an opportunity to validate and inform. Unlike third-party libraries that add layers of abstraction and dependency, the proxy approach is native, lightweight, and direct. It gives you the power to craft custom validation logic, adapt to complex business rules, and minimize the surface area for bugs and security vulnerabilities. By harnessing JavaScript's proxy, you can turn every field into a conversation with the user, one where mistakes are gently corrected in real time, building trust and confidence in your application's data integrity. Think of the proxy pattern as a security checkpoint with a highly trained agent stationed at every possible entrance to your form's state. Any attempt to modify the form's data must first pass through this agent, who not only checks the authenticity of the input, but also maintains a detailed error ledger and real-time report for the user. Unlike static validation, where rules are rigid and only enforced at specific moments, the proxy enables dynamic and context-sensitive validation. For example, a checkout form might require an address only if the user selects a shipping option. With a proxy, this logic resides directly in the interception layer. As soon as the shipping method changes, the validation requirements for the address fields adjust automatically, No manual state management or conditional code scattered through event handlers. This design encourages declarative schemas, where every field's requirements and messages are defined in one place, and the proxy enforces them consistently. Furthermore, the get and set traps allow you to expose the current values, errors, and even custom validation functions through a seamless API, making integration with the UI straightforward. The result is a feedback system that feels almost alive. It adapts as the user interacts, provides suggestions, highlights errors, and validates interdependent fields, all without the need for third-party code. The proxy's ability to encapsulate and centralize validation logic not only makes your forms more robust and user-friendly, but also dramatically improves maintainability and extensibility as your application grows. Consider a complex, multi-step form where different sections become relevant based on earlier answers. For example, an administrative dashboard for managing user roles, permissions, and nested settings. In such scenarios, traditional validation approaches can become tangled, with validation rules spread out across multiple components and event handlers. The proxy pattern, however, excels at handling nested and dynamic form structures through recursive application. When you wrap nested objects, say a permissions object inside a user profile, the proxy can be applied at every level, ensuring that any change, no matter how deep in the structure, triggers the appropriate validation logic. This approach scales elegantly. Rather than writing bespoke code to track changes in every part of the form, each proxy trap delegates responsibility to its children. If a nested field changes, its local proxy validates that field, then bubbles any errors up to the parent proxy, which can aggregate and present them to the user. This recursive strategy means your validation logic remains dry, don't repeat yourself, and easy to reason about, even as your data structures grow in complexity. It also supports advanced use cases, such as dynamically adding or removing fields without additional wiring. The proxy's flexibility empowers you to construct forms that are not only resilient and dynamic, but also maintainable and scalable in the face of evolving business requirements. Real-time feedback is the gold standard for a modern user experience, and the proxy pattern is uniquely positioned to deliver this without the performance pitfalls of constant polling or inefficient re-renders. By intercepting only the operations that matter, property gets and sets, the proxy ensures that validation and feedback are triggered precisely and only when the user interacts with the relevant field. This fine-grained control avoids unnecessary computations and UI updates, resulting in a highly responsive interface. For instance, when a user starts typing a password, the proxy can immediately check for length, character variety, and complexity, updating the feedback layer with actionable suggestions or warnings. If validation involves asynchronous operations, like checking username availability against a server, the proxy can initiate these checks seamlessly, updating the UI only when the result is available. This model outperforms traditional event-based validation, which often requires debouncing, throttling, or batching to prevent performance bottlenecks. With proxy-based validation, you achieve a balance between immediacy and efficiency. Feedback appears when needed, computation is minimized, and the user remains in control. The result is a form experience that feels intuitive, helpful, and lightning fast, all powered by the native capabilities of JavaScript. Comparison with third-party libraries reveals the elegance and efficiency of proxy-based validation. Libraries like Formic or Yup provide rich features, but at the cost of increased bundle size, steeper learning curves, and occasional black box behavior that can make debugging difficult. They often enforce specific patterns and abstractions, which might not fit every use case or team's preferences. The proxy approach, by contrast, is framework agnostic and dependency-free. It leverages the JavaScript language itself to enforce validation logic, leading to smaller bundles, fewer security concerns, and more transparent code. Moreover, because the validation rules and feedback mechanisms are composed directly in your application code, They are easier to test, document, and evolve. This directness encourages best practices. Schemas are versioned and co-located with business logic. Continuous integration runs native unit tests, and type systems like TypeScript can be layered on top for additional safety. Proxy-based validation is not only a powerful tool for custom production-ready applications, but also a strategic choice for teams that value control, security, and maintainability over out-of-the-box features. Security and robustness are critical for production-ready applications, and the proxy pattern naturally enforces a clear separation between client-side validation and the ultimate authority of server-side checks. While the proxy provides immediate, user-friendly feedback and prevents most erroneous data from ever reaching the backend, it is never a substitute for server validation. Instead, think of the proxy as the first line of defense. It catches common mistakes, guides users toward valid input, and reduces friction by resolving issues in real time. This approach also improves accessibility, as error messages and guidance can be rendered contextually, helping users with different needs navigate forms more effectively. From a security standpoint, the absence of third-party libraries reduces the surface area for vulnerabilities, supply chain attacks, and maintenance headaches. By keeping the validation logic native and transparent, audits and compliance reviews become simpler, and updates are less risky. The proxy's centralization of validation rules also minimizes the chance of inconsistent behavior or accidental loopholes. In production contexts where trust, compliance, and reliability are paramount, proxy-based form validation stands out as a robust, future-proof solution. Performance optimization is a key advantage of the proxy pattern for form validation, especially in large-scale applications with complex forms and high user concurrency. Because the proxy intercepts and processes only the relevant operations, such as property changes, it avoids the overhead of global event listeners or state synchronization mechanisms that can slow down the UI. For example, instead of validating every input on every keystroke globally, the proxy confines validation to the field being changed, updating only the necessary parts of the UI. This targeted strategy reduces rendering bottlenecks and keeps the application responsive, even under heavy usage. Additionally, advanced optimization techniques like debouncing, memoization, and selective async validation can be layered into the proxy's traps, providing further control over performance without sacrificing user experience. In scenarios where certain validations are expensive or require server calls, the proxy can defer or batch these checks, updating the UI when results are ready. This approach not only streamlines the validation process, but also ensures that feedback remains accurate and timely. As a result, proxy-based validation delivers not just correctness and interactivity, but also the scalability required for modern, high-traffic production applications. Testing and maintainability are greatly enhanced by proxy-based form validation. The centralization of validation logic within proxy traps means that unit and integration tests can target well-defined, predictable behaviors. Because the validation schema and logic are plain JavaScript, they can be versioned, documented, and evolved alongside business requirements. Automated tests can simulate user input, validate the resulting error states, and confirm that feedback is rendered accurately, all without the need for complex mocking or stubbing of third-party code. This approach also integrates smoothly with continuous integration pipelines, where every change to validation rules can be automatically tested before deployment. Moreover, the transparency of proxy-based validation makes onboarding new developers easier. The logic is clear, discoverable, and closely tied to the application's data structures. Refactoring and extending validation rules become straightforward tasks, reducing technical debt and ensuring that the application remains robust as it grows. By choosing proxy as the foundation for form validation, you are not only improving the immediate user experience, but also investing in the long-term reliability and maintainability of your front-end code base. The future of front-end form validation is likely to be shaped by deeper adoption of proxy-based and similar reactive patterns. As frameworks and browsers continue to evolve, native features like proxy will become even more integral to state management, validation, and user feedback mechanisms. The synergy between proxy and emerging tools such as TypeScript allows for even richer, type-safe validation schemas that catch errors at compile time as well as runtime. Enhanced developer tools and browser APIs will make debugging and introspection of proxy-wrapped objects more intuitive, reducing the few remaining barriers to widespread adoption. Furthermore, the zero-dependency, framework-agnostic nature of proxy-based validation positions it as a foundation for cross-framework libraries, design systems, and shared component libraries. Teams will be able to encapsulate complex business logic, validation rules, and feedback strategies in reusable, maintainable packages that work seamlessly across projects and stacks. As the demand for scalable, secure, and user-friendly web applications grows, the proxy pattern stands out as a future-proof, high-performance solution for dynamic, production-ready form validation and real-time feedback. This is the core JavaScript file for the proxy-based dynamic form validation and real-time feedback system. It demonstrates the integration of the proxy pattern with vanilla JavaScript to intercept form state changes, trigger validation, and update the UI in production-ready front-end applications. This file encapsulates the proxy logic, providing a factory function that creates a proxy object to manage form state and validation. The proxy intercepts property sets to validate inputs and maintain error state, enabling real-time feedback and error highlighting. This file defines the validation schema and functions for each form field. It provides synchronous validation logic for required fields, length constraints, patterns, and password complexity, and exports helpers for validating individual fields and the entire form. This is the HTML markup for the registration form UI. It binds input elements to the JavaScript proxy-powered validation logic and provides containers for dynamic feedback and error display. This file defines the CSS styles for the form, input error highlighting, and feedback messages to ensure a clean and user-friendly UI with clear visual cues for validation failures. This is a unit test script for validation logic, covering required fields, pattern matching, and length constraints. It enables quick verification of the validation implementation using Node.js. This is the package.json configuration file for the project. It specifies dependencies, scripts for development and testing, and browser compatibility targets for the production-ready front-end application. The user registration form appears, displaying fields for username, email, password, profile, first and last name, and address, street, city, country. The user attempts to submit the form without entering any information. Instantly, error messages appear below the relevant fields, and as a summary, clearly indicating which fields are required or invalid. Next, the user enters AB as the username and moves focus away. The interface immediately highlights an error under the username field, stating that the username must be at least 3 characters. The user then updates the username to AB and blurs the field. The form responds in real time, showing an error that only letters, numbers, and underscores are allowed. Typing admin as the username, the user shifts focus and waits. After a short delay, a new error appears, indicating that this username is already taken, demonstrating asynchronous validation feedback. Changing the username to unique user 1, the user moves focus away, and the username field is now marked valid, with all prior error messages removed. The user proceeds to the email field, entering not an email and blurring the field. An error message is shown, instructing the user to enter a valid email address. Upon correcting the input to userexample.com and moving on, the error disappears, confirming real-time feedback. In the password field, the user types password and blurs. The form instantly displays errors about missing an uppercase letter and a number. The user corrects this to strong pass. and the password field is now accepted as valid. For the profile's first name, the user clicks in and out without entering anything. An error appears, stating that the first name is required. The user enters ALCE, triggering an error about invalid characters. After correcting the input to Alice, the error disappears. The last name is filled with Smith and validated immediately with no issues. Moving to the address section, the user fills 12 for the street and blurs, prompting an error that the street address is too short. Changing this to 123 Main St., the error vanishes. The city is entered as New York and the country as USA, each being accepted without issues. The form visually indicates valid and invalid fields at every step, updating error messages and input styles in real time as the user interacts and corrects mistakes. The user scrolls through the form, observing all fields now marked valid and error-free. After a brief pause, the user submits the fully completed form. The registration summary appears, showing all submitted details and confirming successful form submission. The interface provides clear, immediate feedback throughout, powered entirely by proxy-based dynamic validation and feedback mechanisms, with no third-party libraries involved. You've now seen how the JavaScript proxy pattern can transform your approach to form validation, delivering instant dynamic feedback without extra dependencies or unnecessary bloat. By mastering this native technique, you not only streamline your front-end codebase but also gain full control over user experience and application performance. Imagine how much faster and more confidently you'll build production-ready forms. No more wrestling with heavy libraries or generic solutions. To keep leveling up your skills with real-world patterns you can immediately apply, subscribe now. Each video is designed to help you rapidly bridge the gap between theory and practice, so you can build better apps and advance your career with proven, modern JavaScript techniques. Set yourself apart, explore more proxy-powered solutions, and get hands-on with the next tutorial.